Okay, in this lesson we're going to have a look at Unit 4, Chapter 4, Trigonometry in the Unit Circle. We'll be looking at the equation of a circle. Okay, first of all, you should remember that a unit circle is a circle with a center at the origin, 0, 0. The radius is 1 unit, and you can see by the diagram here on the left that I've drawn a unit circle for you, right here. Again, center at the origin, radius 1 unit. If we want to develop the equation of the unit circle, we simply need to consider any point on the circle and represent that point as x, y. Every single point on that circle can be represented using this equation. And we'll create the equation for you. So in other words, x is here, y is here. So the length of this line here is x, and the length of this line here is y. We know from the Pythagorean theorem that x squared plus y squared equals 1 squared. So we get x squared plus y squared equals 1. That is very simply the equation of the unit circle. X squared plus y squared equals 1. Every single point on that circle will satisfy that equation. Every single point on that circle will satisfy that equation. If I want to develop the equation of a circle with a center at the origin with a radius of 2, no longer the unit circle, radius is now 2, we do the exact same thing. OA considered to be of length x, PA is of length y. Now we have x squared plus y squared equals r squared, being the radius squared. So in this case, the hypotenuse of my right triangle is 2, so I get x squared plus y squared equals 4. There's the equation of the circle of radius 2. And in actual fact, what I started with here represents the equation of a circle with any radius. X squared plus y squared equals r squared. Doesn't matter what the radius is. The equation will be x squared plus y squared equals r, being the radius squared. In this particular case, it was x squared plus y squared equals 4. Don't forget that r has to be squared, of course. Next example. It says, determine the coordinates for all points on the unit circle that satisfy the conditions given. And notice it does say on the unit circle that satisfy the conditions given. Draw a diagram in each case. Okay, let's construct a diagram. Let's draw our unit circle. So this is a unit circle. We're looking for the coordinates of all the points on that circle that satisfy the condition where the x-coordinate is 2 over 3. The x-coordinate is 2 over 3. So I'm looking at a point right here that has an x-coordinate of 2 over 3, and we're looking for the y-coordinate of that point. Now we should also recognize that on a unit circle, the coordinate 2 over 3 also occurs right here, because we know that x is positive in both quadrants 1 and quadrants 4. So we're trying to find the y-coordinate of this unit circle. So again, because it's a unit circle, we know that the radius is 1. So I'll just construct the radius here for you. Radius is 1. We can use our formula for the equation of a circle, unit circle in particular, to find the value of y. So because it's a unit circle, x squared plus y squared must equal 1. The x-coordinate is 2 over 3. The y-coordinate is what we're looking for. 2 over 3 squared is 4 over 9, plus y squared equals 1. Y squared will equal 1, subtract 4 over 9. Y squared will equal, that's 9 over 9, subtract 4 over 9, which is 5 over 9. If we want to finish it over here, y will equal plus or minus the square root of 5 over 9, which will give us plus or minus the root of 5 over 3. Now we need to consider, are both of these answers suitable? And the answer is yes, they are. Because in quadrant 1, y is positive root 5 over 3. And in quadrant 4, y is negative root 5 over 3. So we do have two values for y. It says determine the coordinates of all the points on the unit circle, you see. That has an x-coordinate of 2 over 3. One will have a coordinates 2 over 3 and positive root 5 over 3. I should fill them in for you. And the other one will be 2 over 3 and minus root 5 over 3. Okay, let's have a look at B. If the y-coordinate was negative 1 over root 2, and the point is in the quadrant, quadrant 3. So now they're very specific now about where the point is located. Let's do B over right here. So let's draw a diagram, again, of the unit circle. Here it is. And we have a point in quadrant 3, and the y-coordinate of the point is negative 1 over root 2 in quadrant 3. We're looking for now the x-coordinate of that point. Again, because it's a unit circle, the radius is 1. If the radius is 1, we can use our formula for the equation of a unit circle as x squared plus y squared equals 1. We'll solve this for x this time. Plug in our point, x squared plus y squared, negative 1 over root 2, squared equals 1. X squared plus 1 over 2, 1 squared is 1, root 2 squared is 2, equals 1. X squared is equal to 1 minus half, so x squared is equal to 1 half. So therefore, x is equal to plus or minus the root of 1 half. Plus or minus the root of a half. Which I guess we can write it as plus or minus, the root of 1 is 1 over root 2. And because they left the radical in the denominator here, in the original question, I guess I can leave the radical in the denominator there, I guess. You know, I could multiply by root 2 over root 2 to get root 2 over 2 as well, of course. But because they left it here, I will leave it here. Now, notice we got two answers again, plus or minus 1 over root 2. We are looking for a specific answer this time because we're looking for the point in the third quadrant. In the third quadrant, x is negative. So as a result, the answer they're looking for this time is going to be the point negative 1 over root 2 and negative 1 over root 2. So we'll look at another example. What is the equation of a circle with a center at the origin and passing through the point 4, 3? Again, if you want to try this one before I actually do it, you might want to pause the recording and do that. So now we have a circle, and we have a point on the circle is x is 4, y is 3. X is 4, y is 3. If x is 4 and y is 3, you should recognize that this is no longer a unit circle. X is 4 and y is 3. This is a circle with a different radius than 1. Let's determine what the radius is. 4 squared plus 3 squared will equal the radius squared, using the Pythagorean theorem. 16 plus 9 is equal to r squared. 25 is equal to r squared. R is equal to the root of 25, and r is positive, so it has to be a positive 5. Not necessarily, I know when solving r squared equals 25, I probably should write plus or minus root 25, I guess. But we know because the radius is positive, it's the length of a line, so we're going to use r equals 5. So the radius of this circle is 5. So the equation of this circle is going to be x squared plus y squared equals r squared. which is x squared plus y squared equals 5 squared, which is going to be x squared plus y squared equals, of course, 25. Correct answer is C. Another example, the point P, x comma negative 3 over 8 lies on the unit circle in quadrant 3. What is the value of x? Similar to the one that we did earlier. Again, if you want to pause the recording and try this one, you probably should. I will proceed to do it. We're in quadrant 3 again. So let's draw our circle, and it is the unit circle. That's important. It's on the unit circle that's stated right there. So we know it's a circle of radius 1. Let's just move my circle so it's a little better centered here. There we go. And let's draw a terminal arm located right here, because we are in the third quadrant. The radius is 1. The point is x comma negative 3 over 8. Again, we're looking for the x coordinate of the point. So again, we're going to do x squared plus y squared equals 1 squared, because it is a unit circle. X squared plus a negative 3 over 8 squared equals 1 squared. X squared plus 3 over 8 squared, or negative 3 over 8 squared, is 9 over 64 equals 1. X squared will equal 1 subtract 9 over 64. X squared will equal 64 over 64. Subtract 9 over 64. So x squared will equal 55 over 64. So x equals plus or minus the root of 55 over 64, which will be plus or minus the root of 55 over 8. Plus or minus the root of 55 over 8. In the third quadrant, you should recognize that x is negative in the third quadrant, and that's the only answer we're looking for now. So we're looking at x being negative root 55 over 8, and y is negative 3 over 8. Negative root 55 over 8. The answer is D. Okay, summarize the key ideas here. Simply this. The equation of a unit circle is x squared plus y squared equals 1. It can be used to determine whether a point on the unit circle, it can be used to determine whether a point is on the unit circle, or to determine the value of one coordinate given the other point. The equation of the circle with a center at 0, 0 and a radius of r is given by x squared plus y squared equals r squared. And that ends this lesson.